Okay, so this is the last video for week 7. We're going to talk about how the hormones regulate fat and carbohydrate metabolism during exercise. So there are our objectives. So if you've gone through the first 7 videos, hopefully you've caught that there's a bunch of hormones that are involved in carbohydrate metabolism. Okay, and these are glucagon, epinephrine, norepinephrine, and cortisol. Okay, and the way that this works is they can do a couple of different things. They can cause glycogenolysis, so that's the breakdown of glycogen. Remember, that's stored in the liver and the muscle. And glycogen are just chains of glucose molecules. So we break those chains and we end up with individual glucose molecules. All right, and as a result, we've got stuff that can be taken up by the muscle cell so that we can use it for energy. But if I've got glycogen in the muscle, the best place to break down glycogen would be in the muscle. Then we've got something called gluconeogenesis. So this is where we take something that isn't glucose and isn't glycogen, and we form glucose. So lactate, we've talked about that with the Cori cycle. Glycerol, the backbone of triglycerides, and amino acids. Okay, all of those can be used to form glucose. Now during rest, when it comes to releasing glucose, glucagon's the one that does the job. Okay, it breaks down liver glycogen, and it can also cause gluconeogenesis from amino acids. Okay, so when you're just hanging out here, just relaxing, and you need an increase in blood glucose, it's glucagon that's causing that. However, during exercise, we increase not only glucagon, but epi and norepi, and these work to cause the breakdown of glycogen. Over time, over long duration exercise, cortisol then comes into play. Okay, so over the first 45 minutes or so, cortisol secretion increases, which causes breakdowns of proteins, and these proteins can be used to produce glucose, so that gluconeogenesis. All right. Now, the release of glucose is dependent on how hard you're working and how long are you working for. All right, and so if we've got big intensity or large intensity, high intensity, that's the word I'm looking for, then we're going to release a lot of epi and norepi. Now at the beginning, glucose concentration spikes a little bit. All right, and the reason that this happens is because we're producing more glucose than we're using. All right, now this is different than the spike that we saw earlier in the semester where we had somebody eat a whole bunch of sugar or have like a sugar feeding right before exercise. Okay, your blood glucose isn't going to spike that much. And that big of a spike is bad, as we saw, because it will create such a big gradient. It makes it very easy to deplete your blood glucose. Now, when it comes to long duration exercise, things are a little bit different. Okay, blood glucose generally stays close to resting values. The amount that's taken up by your muscle ends up taking up a bunch, and so we release glucose from our liver. So blood glucose ultimately stays constant until we deplete our liver glycogen, and that takes a while. This is like marathoning, okay? And when this happens, we'll release more glucagon and cortisol. Remember, gluconeogenesis. After exercise, last thing that we're going to talk about before we jump into fats is blood glucose concentration decreases because glucose is still taken up by the muscle. We have to replenish, or we will replenish, the glycogen stores that were in our muscle that we've initially used. Okay, so blood glucose will be lower than normal after exercise because we're still, even though we're not exercising, glucose continues to go into the muscle cell to replenish glycogen stores. So let's talk about fats for just a minute. Fats, large source of energy, arguably endless supply. Like you're not going to go through 80,000 calories or 70,000 calories. Okay, at least not in a short period of time. And fats are important for endurance performance because it's usually low intensity, long duration, right? But in order to use these, we have to break them down into triglycerides, and we can find these triglycerides not only in fat tissue, adipose tissue, but also in the muscle. And so when we break them down, when we break fats down into fatty acids, we call this lipolysis. These fatty acids are then able to be taken up into the cell where they're broken down via beta oxidation. Okay, and the hormones that help with that are insulin, which we talked about, epinephrine and norepinephrine, which we've talked about, and cortisol. The other one that helps with fat metabolism is growth hormone. So last thing that we're going to talk about is exercise. There's also a hormone called leptin. And if I have low amounts of leptin, then I'm going to have increased lipolysis. Leptin actually causes the creation of fat. All right. And so if I've got low levels of leptin, that allows me to break down these fats so I can use them for energy. And this is lipolysis. And if I've got lots of epi or norepi floating around, that will also stimulate the release of, or stimulate the process of lipolysis. Cortisol also plays a role in that after 45 minutes or so, we can start to use these free fatty acids because of cortisol. The other stimulus for fat metabolism is if we have low levels of carbohydrates, because we've depleted our glycogen stores, we can break down fat so we can use that for energy. But remember, when we use fat, it takes a little bit more oxygen to use, and it's a slower process. So our intensity we won't be able to maintain the same intensity. And that is the end of the endocrine system.